All right, section 4.1. As we start chapter 4, we get into the normal curve, which is a bit of a change up from what we have been doing in stats. It kind of changes into a different part of statistics, and it starts with the normal curve. And we're going to use this along with one of those sheets you picked up at the drive-through that has the normal curve and has the z-scores on it. That's going to be something we're going to use quite a bit as we go forward. So the question we're going to answer is, what are the characteristics of a normal curve? Right, a density curve is a smooth curve used to approximate a distribution. Okay, so this is a special density curve. Okay, the normal curve is special because it's completely uniform, and we're going to talk a little bit about what that means. The characteristics of a density curve is it is a curve drawn through the tops of the bars of a histogram. And it has been a while since we've talked about histograms, but if I zoom in, you can see that there are a bunch of rectangular bars that make up this normal curve. Okay, and the normal curve goes kind of through the tops of those bars to make a nice smooth line up and around. So it's not choppy like steps, it's a nice smooth line. Okay, the second characteristic is the curve describes what proportions of the observations fall within a given range. Okay, it is always constructed on or above the horizontal axis. All that means is there's never going to be ones that come down like this. That's never going to happen. It's always going to be on or above that. The total area underneath the curve is always represented by 1. Okay, and the reason that is because think of it as 1 is 100%. So 100% of, like, let's say you're going to do the test scores in a classroom, okay? All of the test scores have to be underneath that curve. Okay, so 100% of the test scores will be in there. Okay, and it'll make more sense as we go on with this. The area underneath the curve, but trapped within an interval of values, is the proportion of all values that fall within that range. So this curve is not perfectly normal. You see it's kind of like skewed off to the left, but this area right here is a percentage of the whole curve, basically. So this chunk that's shaded in red is the region between 7 and 8. So like, let's say with kids, they want to know how many pounds did you gain in a year. You know, as kids grow up, they want to see, how fast are kids growing. You go to the doctor, get your checkup. So between 7 and 8 pounds would be all the kids right here. So, and it's a percentage. So you see it says area is 0.12. It's kind of like saying 12% of people would gain between 7 and 8 pounds. That's a hypothetical example, but it's a percentage of the whole curve. So think of it as the entire area underneath here is 100%, and this part is a part of the 100%. All right, and the curve is an approximation that is easy to use and accurate enough for practical use. Okay, it's not exact. We use it to approximate how things happen. All right, because the density curve is an idealized description of the distribution of data, we distinguish between the mean and the standard deviation of the actual observations and the mean and the standard deviation of the density curve. So X bar stands for the mean of observations. So it's how many did you actually see happen. All right, and then this like cursive U stands for the mean of the density curve. So X bar comes from a sample, and U comes from a population. Okay, and again, we're going to get more into that. S will stand for the standard deviation of the observations. Again, this is from the sample. And then this is called sigma. That stands for the standard deviation of the density curve. So the population. Okay, and so like these curves up here, they're made with information and data from over years and years and years and years and years. Okay, that's how they kind of come up with like your average height at age 8. Or when you take your tests, like your ACT and your STAR test, they tell you you're in like the 95th percentile or the 75th percentile. Because over years and years and years and years, that's kind of where the scores have been for the 75th percentile. Okay, and then the sample is like when you have a specific 20 people you're looking at. So normal distributions are density curves that are symmetric, they are single peaked, they are bell shaped, and they are centered at the mean. So this will be centered at the mean. So if I draw a picture, I'll zoom in, I'm going to draw a picture right here. So this is our horizontal axis, and some of these don't always turn out great, but it's going to go up, and then it's going to come down about just as fast. So it's completely symmetric. There's one center. It's going to be directly in the middle. That's going to be where the mean is. Okay. And I want to point out that the mean and standard deviation control the shape of the normal density curve. The mean is the center of the normal distribution along the x-axis, and the standard deviation controls the height and stretch of the curve along the x-axis. So the bigger the standard deviation, the more spread out it is. So if I come down here, if I draw a normal curve, okay, it will look like, I'd say that's my normal curve. Not perfect, but it'll work. Okay, in the middle is the mean. Okay, if you go over a little bit, this distance from here to here is called the standard deviation. And the larger the standard deviation, the more spread out it is. So the larger the standard deviation, the more spread out it is. Empirical rule is 68, 95, 99.7 rule. This will come back up. I'll come back to it and I'll explain this again later, but that's the empirical rule, which is what we kind of fall back on. Okay, normal distribution. In a normal distribution with the mean U and the standard deviation sigma, okay, about 68% of observations fall within one standard deviation from the mean. Okay, about 95% of observations fall within 2 standard deviations of the mean. Okay, and then about 99, oops, let me erase that. 0.7% of observations fall within 3 standard deviations of the mean. This is the empirical rule. So if we look at the picture below, what that means is if the mean is in the middle, the mean is 0 away from the mean. The mean is the mean, it's 0 away. 1 standard deviation to the right and 1 standard deviation to the left. In between here is going to be 0.68. Okay, you can see 0.68 of the data is between here, which means roughly 0.34 is to the left and 0.34 to the right, because half on the left, half on the right. It's symmetrical. Okay, and then if we extend that out a little bit from here to here is 95%. Half of 95 is 47.5. So this would be 0.135, 0.135, because if you add these all up, you would get 95. Okay? And then let me change colors. All the way out to 3 standard deviations, so 3 to the right and 3 to the left. That will be about 99.7. So this would be 0.0235. Because if I add these up, this would be 99.7. Okay, and then lastly, way outside is going to be 0.0015. Because if you take 99.7 plus 0.0015 and 0.0015, you add those up, you'll get 100%. So that will make up 100% of the numbers that would go into this curve. Okay, but just know that almost all of the data is within 3 standard deviations. So think of it like if the mean is 20, and if you go 1 standard deviation above, let's say that goes up to 22, 1 standard deviation below will go down to 18. So you go 2 above and 2 below. Okay, another standard deviation will go 2 more to the right and 2 more to the left. So that's kind of how we're looking at that. It's going to go up by a standard deviation, which is a fixed number. Okay, so in example 1, it kind of goes into a little more depth. Let's say we have a distribution of weights of male teachers at Logan High School, and it's approximately normal with a mean of 200 pounds and a standard deviation of 25. Make a normal curve labeling the mean and values of each standard deviation up to 3 standard deviations. So you start by drawing a horizontal line, and then try your best to make a normal curve. It's not always perfect. This one is not perfect, but it's not bad. I mean, it shouldn't, like, I'm okay with this. I would not be okay with, actually, that's not even the worst. I've seen a lot worse than that. As long as it's not absolutely terrible, I'm okay. Like, I understand that it's not going to be perfect. Okay, if the mean is 200, that means in the exact middle, the mean 200, that goes in the middle. If a standard deviation is 25, that means 1 standard deviation is 1 to the right and 1 to the left. They should be about the same distance. 25 above is 225. 25 below is 175. Okay, so about, based on our rule, about 68% of people will be between 175 and 225. If you go 1 more standard deviation, okay, this would be 250 because it's 25 bigger, and 150. About 95% of people will be between those 2 weights. If you go 1 more, it will be 275 and 125. About 99.7 will be between there. So notice that that's 3 standard deviations. 1, 2, 3 to the right, 1, 2, 3 to the left. About the same distance away from the mean. So if someone weighed 210 pounds, they would fall right about here. They would be in this section. If someone weighed 270 pounds, they would be out here. Okay, and now you kind of see where the percentile comes from. Okay, what percentile you fall in depends on where the standard deviation is and comparative other data we have. So example 2. Let's say we have a distribution of heights of young women aged 18 to 24. Is approximately normal with a mean of 64.5 inches and the standard deviation of 2.5. Make a normal curve, labeling the mean and values. So we have is a horizontal line. And again, try your best. I don't want it to look like this. That's clearly not a normal curve. As long as it's close to looking correct and it's close to normal, I'm all good with it. So gradually up and gradually down. Okay, not perfect, but it's pretty close. So the mean will go in the middle. I would cut it in half. The mean is 64.5. If you go 1 standard deviation to the right and 1 to the left, should be about the same distance, 2.5. So 2.5 bigger is 67. 2.5 smaller is 62. You go 1 more standard deviation to the right and 1 more to the left is 2.5 more. So this would be 69.5 and 59.5. And then your last one is 1 more to the right, 1 more to the left. And this would be at 72, and this would be at 57. Okay, so that's our normal curve with our standard deviation. And that's all we start with.